Okay, we are going to get started in section 1.4. And in this section, we're talking about ways that we can combine functions. So the first way we can combine them is using algebraic operations. Okay, so if we have two functions, f of x and g of x, and they have real number outputs, so the kinds of things we'd expect, we define new functions. We can add, subtract, multiply, and divide in the following ways. So if f plus g of x is just equal to f of x plus g of x, f minus g of x is equal to f of x minus g of x, f times g, so if they're both together inside the parentheses like that, of x, that's f of x times g of x, and f divided by g of x equals f of x divided by g of x. So pretty intuitive, just what you'd expect, as if they were numbers. Do you see anything we have to be careful of here? How about this denominator here? We cannot divide by 0, right? So we have to be very careful of what the domain of this new function is going to be based on where g of x might be 0. So let's do an example. Here we've got, it says find and simplify these functions, g minus f of x and g divided by f of x. And they tell us f of x is x minus 1, and g of x is x squared minus 1. Let's see if I can make this full screen. And they ask us, are they the same function? Okay, well, let's look first at g minus f of x. Okay, so obviously we have to pay attention to which comes first. So we'll write this is equal to g of x minus f of x. We just keep the order. And now we just plug in the values that they give us here in the problem. So g of x is x squared minus 1 minus f of x. We have a minus sign, and we have to be really careful with minus signs, right? We need to be sure we distribute it to each of the terms here. So this is going to be x squared minus 1 minus x plus 1, right? If we distribute that minus to both terms. Okay, we've got a minus 1 and a plus 1, so we can write this as x squared minus x. Okay, there we go. That's g minus f of x. Now let's find g divided by f of x. So g of x is on top, and f of x is on the bottom. Okay, so let's see, g of x is x squared minus 1, and f of x is x minus 1. Do we see anything we have to be careful of? Yes, right? This denominator cannot be 0. So we're going to have to restrict the domain and say x is not equal to 1. As long as x isn't equal to 1, we're good. So notice that both g of x and f of x, they're just polynomials, right? So their domains normally are all real numbers. But here we have to restrict it for their algebraic, connecting them algebraically. Oh, look, there's a spider crawling across the paper. That's a real spider, not like something on my computer screen. So we're just going to keep going. All right, so can we simplify this at all? X squared minus 1. Can we factor that? It's a difference of squares, right? So we can write that as x minus 1 times x plus 1 divided by x minus 1. We have to keep this restriction on the domain. And yes, we've got a factor here and a factor here that match. So we can simplify this just to be x plus 1 with the restricted domain, x can't equal 1. Can we just get rid of this now? Because now we don't have a denominator anymore. We cannot. Okay, we will talk about, we call these rational, we'll talk about this in future lessons where we have a polynomial over a polynomial. Even if we can simplify it out, we cannot get rid of this restricted domain. Okay, that needs to stay. So to have a completely correct answer, we need both parts. We need the simplified function, and we need the restriction on that domain. Okay, and the question asked if these are the same function. We can look, and obviously they are not. We could, I guess up here, if we wanted to, we could simplify this and say x times x minus 1. I don't know why we'd have to do that, but that makes it even more clear that they're not the same functions. Okay, so algebraically combining functions is just what you'd expect. The only thing that is a little bit tricky is being sure if you have something in the denominator that you have to restrict the domain.